All right, let's get through the rest of this lesson of graphing and talking about lines. The next part of the lesson we need to talk about are parallel and perpendicular lines. We should know the definition of parallel being two lines that have the same slope that don't intersect each other. All right, so parallel lines are going to have exactly the same slope. Perpendicular lines are two lines that intersect each other and form a right angle. We're going to say that perpendicular lines have the negative reciprocal slope. So if my original slope was 2/3, my perpendicular slope is going to be -3/2. So I'm going to flip the fraction over and change the sign. Negative reciprocals, flip the fraction, change the sign. So I'm going to give you a situation, and I'm going to ask you to write the equation in slope-intercept form. I'm going to ask for y equals mx plus b. All right, there's a line that passes through the point -710 that is parallel to the line 2x minus 3y equals -3. So if I graph this line, and then the line that's parallel to it that passes through this one, I'm going to get two parallel lines next to each other. They're going to have the same slope, but different y-intercepts. So the first thing I'm going to do, I'm going to find the slope of this original line. All right, so I'm going to subtract the 2x and divide by -3. So my original line has a slope of 2/3. So the line I want to find, the parallel slope, is also going to be 2/3. So that's half my answer. So I found the slope of this line. And since I want a parallel line, I'm going to use the same slope. Now, like we did in the last couple, I'm going to use this slope and my point to find my y-intercept for my new line. So I'm going to substitute the 10 and the -7 in. It looks like I'm going to get some fractions. 10 equals 14/3 plus b. So I'm going to add a 14/3. And then you start scratching your head. All right, I'm going to move it over here. To be able to add two fractions together, two numbers together, one being a fraction, we need common denominators. So since my second one has a denominator of 3, I'm going to put a 3 on the top and the bottom of this one. So now, 30/3 plus 14/3, which is going to give me 44/3. And just because it's a fraction doesn't mean it's wrong. So I had to force common denominators and change 10 into 30/3. Do my math. I get y equals 2/3 x plus 44/3. Fractions are not your enemies. I think decimals are a lot harder. So we've got to be able to work with fractions and be able to add and subtract. So going back to the start. My line I wanted is parallel to this one, so I found out what its slope was, and I used the same slope again. And then like the last two problems, I used that slope and that point to find me the y-intercept. No difference, just we had to find the slope of this one here first. All right, the next one passes to the point -2, 1 is perpendicular to the line 3x plus y equals 1. Passes through the point -2, 1 and is perpendicular to the line 3x plus y equals 1. So the first thing we're going to do, I'm going to find the slope of the line they gave me. All right, but my answer needs to be the perpendicular slope. And the slope that's perpendicular to -3 is its negative reciprocal. So it's going to be positive. Let me do this. Make it a fraction. So the slope I'm going to use is a positive 1/3. So this is going to be my answer. finding my y-intercept. So I'm going to use that point and this slope. 1 equals 1/3 times a -2 plus b. 1 equals -2/3 plus b. Add a 2/3. And I'm going to go 1 plus 2/3, which is the same as 3/3 plus 2/3, which is 5/3. So I had to force common denominators. 1 is the same as 3/3. And 3/3 plus 2/3 gives me 5/3, which gives me the line that's perpendicular to this, going through the point -2, 1. All right, so you just got to understand how to find a perpendicular and parallel slope. All right, let me go all the way back to the beginning. We skipped these because it's a little bit easier, and I wanted to go over the hard stuff in class. All right, a few definitions. A relation is going to be a set of ordered pairs. It can be written several ways. As a mapping, as a graph, as a function, all these different ways are just as ordered pairs. Your domain we know is your x value. We're going to call it the independent variable. The range is going to be your dependent variable because it depends on your x, which is my y value. I'm going quick, so pause if you need to at any point. The function is a relation in which each element of the domain is paired with exactly one element of the range. All right, this means you cannot have the same x going to two places. You can't have the ordered pair 3, 4 and 3, 5. That's bad. That's not a function. It also has to pass the vertical line test. If it passes the vertical line test, which means it only touches the graph once, it is a function. All right, so given this, I'm going to give you this relation. My relation consists of the points -1, 3, -2, 1, -3, 3, and -4, 0. You're going to tell me if it's a function or not. And then we're going to state the domain and range. There's a couple little things about the domain and range to make it easier. All right, but first off, is this a function? Do I have the same x value more than once? And I'm going to say no. So when I say no, it is a function. When I don't have the same x more than once, it is a function. My domain are my x values. So I'm going to pick out all of those x values and put them in order from the smallest to the largest. When you see these, you're going to see these all different ways with some brackets, some braces, all these different things. As long as you understand that they're the same, I'm okay. Now my range in order is -3, 0, 1, and 3. So here's my domain and range, my x values for domain, range for y values. And since it passes the idea that you can't have the same x more than once, it is a function. All right, looking at this next one. -2, -1, -8. I have the same x value twice here. It's not a function automatically. All right. But I have these 6 ordered pairs. Now for my domain, I'm going to pick out, again, all these x values, and I'm going to put them in order. -2, -1, I'm not going to write it twice. 0, 1, and 2. The range in order 0, 1, and 8. All right, so pick out your x values, write them in order, smallest to largest. Don't write them more than once. Same thing for the range, or your y values. This is not a function because I have a double x value. All right, number 3. Now we're going to start looking at graphs. We're going to do these a little bit differently, but we're going to use the same ideas. To decide if it's a function, when I draw all these vertical lines, if I ever touch the graph more than once, it's not a function. But each time this yellow line only touches once, we get rid of all of them now. So we're going to say that this is a function. All right, now we got to start thinking a little bit differently. My domain is not these 4 points. Those are the obvious points. My domain are also all the numbers in between. So all the numbers in between. So my domain, what I'm going to say, my domain are all the x values between -6 and +4, because that's where my graph is. So I'm going to say that -6 is less than x, which is less than or equal to, if we're going to do equal to on both of them, than 4. So I'm going to start at -6, and I'm going to go up to 4. So I say -6 is less than or equal to x, which is less than or equal to 4. For my range, I'm going to look at my y values. My lowest y value is at -1. My highest y value is at 4. So for my range, I'm going to go from -1 is less than or equal to y, because I'm talking range, less than or equal to 4. These say my y is between -1 and 4. My x is between -6 and 4. And because they're endpoints, I want to make them equal to. So we have to look at the graph and decide where our domain is, like where it starts and where it stops. All right, so for number 4, automatically right in the middle, I have this oval that fails the vertical line test. It's not a function. My domain, my left value, it starts at -3, and it goes to +3. -3 is less than or equal to x, which is less than or equal to 3, and this is how we're going to write it. It's an and statement. My range starts at -2 and goes up to 2. All right, so this is like between. My x's are between -3 and 3, -3 to 3. My range, my y's, y, not an x, y's, are from -2 to 2. All right, this is what's called a mapping. This mapping consists of 5 ordered pairs. 6, -5, 7, -5, 8, -5, 9, -5, and 10, -5. That's what it means. So looking at this, I'm going to say this is a function because I only have 5 ordered pairs. Doesn't matter they all go to the same place. All that matters is I don't have this number twice. And to make this easier, this first circle is my domain. My second one is my range. That's just how it's set up. All right, and lastly, this one over here, I'm going to say it's not a function because I have the ordered pair 3, 7, and 3, 10. And the same idea, my domain is the first one, my range is my second one. All right, so that wraps up the lesson. I know it was very quick. Slow it down, pause if you need to go back and do it again, look at it. All right, I'm going to post this with the homework already online. This is due not next class, but the following class. So my white day is going to be due on Tuesday. My green day is going to be due on Wednesday. A week from today it's due. All right, have a great day and contact me if you have any questions.